Hello again, chemistry. This is 2.2 unit conversion. All right, the first part of our notes has a very handy table, unit conversion equations between metric, which is this side here, and English, which is what we commonly use in our everyday lives in America. But for science, we're mostly going to be using the metric system. So we're going to use these helpful conversion equations in this lesson. All right, the first task is to use the metric system, use those base units to figure out how many, for instance, millimeters are in a meter. So we have some common prefixes down here. You can also use that prefix table in your previous notes. 1 meter, how many millimeters are in a meter? Since I know milli means 1/1000th, then I would guess that there's 1,000 millimeters in a meter, and it's true, there is. You're going to pause your video and fill in your notes here. Okay. See how you did. There we go. There's the answers. Check your answers. See how you did. Okay. Now we're going to do a little fraction review. We're going to remember 2 techniques in working with fractions that we're going to use in our unit conversion practice. The first technique is cross-canceling. So let's say I want to multiply 3/5 times 7/3. I could just go about it the usual way where I multiply across the top and across the bottom. But then I would have to simplify by dividing by 3, right? And get 7/5. Alternatively, I could use the cross-canceling technique, and I could say that, well, that changed everything. I only wanted to change one thing. I could say that I see a 3 here on the top and I see a 3 on the bottom. When they're diagonal from each other, you're allowed to cancel them before you multiply. Because what you're doing is you're saying, wait, those are both 3 is divisible by 3, and this 3 is divisible by 3. If I do the same thing to the top and the bottom, that becomes 1 and this becomes 1. Then I can multiply and I get 1 times 7 is 7, 5 times 1 is 5, and I get the same thing, but I didn't have to simplify at the end. It's like I simplified first. So that is cross-canceling. We're going to remember that technique. We're going to use it in the next section. All right, now let's practice. I didn't want to change everything. I just wanted a new color. All right. Now let's practice a technique we would use for changing the denominator. So let's say we have 1/2, and we want to express it as some number of sixths, right? So you might say, okay, well, I would like to, maybe I change it here. I think what I'm going to do is I'm going to multiply the bottom by 3, right? That'll give us 6. 2 times 3 is 6, but then I should also do the same thing to the top, right? So my equivalent fraction is 3/6. We know that 1/2 is equal to 3/6. I have not changed the quantity. And the reason I have not is because I've done the same thing to the numerator and the denominator of the fraction. Essentially what I've done is I've multiplied 1/2 by 3/3. And 3/3, as you might remember, is equal to the magical number 1. Woo! Anytime you multiply a number by 1, you have not changed its value. So let's remember that as we move on to our dimensional analysis technique for unit conversions. This technique is super duper useful in chemistry. We're going to use it all year for all kinds of different things. Today we're using it to convert from one unit to another, from centimeters to inches. Now you might look at this and say, oh, I have a really easy way of doing this. I just divide by 2.54. And you would get the right answer. But you would not have practiced or learned dimensional analysis, which we need to know for chemistry, and we're going to be using on much more difficult problems. So to get credit for this assignment, you do have to use this technique, which will feel confusing at first, but then really feel like second nature. If you were in 8th grade science, you did this with me, and it is somewhere somewhere in the recesses of your memory. Okay, the first thing I'm going to do is I'm going to think to myself, okay, I'm trying to convert from centimeters to inches. I need an equation that tells me how many centimeters are in an inch. So you would go back to the top of your notes here to this little table. And we see, look at this, we have an equation right here. Inches and centimeters. 1 inch equals 2.54 centimeters. Okay, we're going to take that back to our problem. There we go. And we're going to write it here. 1 inch equals 2.54 centimeters. And then we're going to make an estimate. Is my new number going to be bigger or smaller than 448.7? When I express it in inches, am I going to have 448.7 inches, more than 448.7, or less than 448.7? Because inches is a bigger length than a centimeter, I'm going to have that same length expressed in inches is going to be smaller. That will help us check if our answer is reasonable. Okay, moving on to doing the problem. Step 1, start with the original quantity and unit. Make it into a fraction by placing it over 1. Our original quantity is 448.7. Put it over 1. All right, we did step 1. Yay! Okay, step 2, place the units in the conversion factors. This next fraction is called the conversion factor. And we know that we want to cancel centimeters. So we want to have centimeters on the bottom here. That's going to allow us to do that cross-canceling technique in a moment on step 4. And then we want the units that we're supposed to convert into, inches. We'll put that on the top. Then step 3, place the numbers correctly in the conversion factors, making sure the numerators are equivalent to the denominators. All right, and match our equivalency equation. So here's where we use this equation, right? We know that 1 inch equals 2.54 centimeters. And we are allowed to multiply our original number, 448.7 centimeters, by this conversion factor because that conversion factor is equal to 1, right? It's equal to 1 because 1 inch is equal to 2.54 centimeters. That's why we're allowed to do this and not change the value of the length we started with, 448.7 centimeters. Okay, step 4. Cancel the units and multiply. All right, so let's see if I can use a different color here. All right, I'm going to use red. So we have centimeters here, and we get to cancel it with centimeters there. That step is so fun. And then we're going to multiply across the top. 448.7 times 1 is 448.7. 1 times 2.54. We should have a calculator out. Pause and get your calculator. We're in inches now because we canceled out centimeters. And I'm going to do that. 448.7 divided by 2.54 is equal to 176, I think I'll just round to the nearest hundredth, 0.65 inches. That's my answer. I'm going to put a box on it. And indeed, my new number is smaller than 448. So I went in the right direction at least. I didn't make a huge error. So now we're going to move on to the next one. Let's try this one. Okay, we're going to do the same thing again. Converting 846.9 kilograms to pounds. So I need an equivalency equation. So again, I'm going to have to go back up to my table. And I have kilograms and pounds. 2.2 pounds equals 1 kilogram. All right, let's take that back here. Ooh, that makes me dizzy. 2.2 pounds. Oops. Here's my decimal. And there's my eraser. Whoa. 2.2 pounds equals 1 kilogram. Okay. Will my new number be bigger or smaller? I'm expressing something that was in kilograms into pounds. There's more than 1 pound in a kilogram. I'm going to predict my new number will be bigger. All right, now we're going to do the same technique. Start with the quantity, original quantity in unit. Okay, that's what I'm starting with. Putting it over 1. Place the units in our conversion factor. Where do we put the kilograms? Well, we put them on the bottom because we're going to want to cancel, right? Where do we put the pounds? On the top. Did step 1 and 2. Now we're going to place the numbers. Okay, this is important. How many pounds equals how many kilograms? I'm looking at my equation here. And it's 2.2 pounds equals 1 kilogram. Sometimes people mix it up and they might put the 1 on the top. 1 kilogram equals 2.2 pounds. It's important that it matches the equivalency equation. 2.2 pounds equals 1 kilogram. Or you'll get the answer wrong. Okay, now I'm going to digitally change colors. Whoa, I didn't want all the colors to change. Good grief. How does this work? Okay, I think if I change... all right, it's all red. No, I'm going back to purple. You mock me, iPad. Okay, so kilograms cancels, right? I canceled the units. Now I'm going to multiply across the top with my calculator. 846.9 times 2.2. I got 1863.18. 1 times 1 on the bottom. And I am in pounds. All right, I don't need to write the 1, right? Because anything divided by 1 is just itself. Here we go. That's my answer. Let's see, was my answer bigger? I predicted it would be bigger, and it is. So I'm gonna smile like my chemistry spirit animal, the quokka. Quokku? I'm very unfamiliar with that animal still. Gotta look up what it's called. Okay, moving on. Ooh, your turn to try on your own, friends. Okay, so try these on your own. Make sure you pause the video right now. Give them a try. See how you do. You can look back, follow the same steps you followed, and then check your answers. Again, in order to get credit on these notes and on the homework assignment, you need to have your answers, have your work shown and have it look like this here, where we're really right in the conversion factor, canceling. It should look nice and messy. Not necessarily messy, but it should look like this, which is admittedly a little messy. Okay, trying these on your own. Okay, friends, pause the video. Welcome back. The big reveal. Ooh, how'd you do? I think I was, in my digital thing, I was unable to actually digitally cancel, so I'm going to do that here, right? Kilograms canceled with kilograms, milliliters with milliliters. Those should have been your answers. Okay. Sometimes we need to use more than one unit conversion factor. That's when the fun really gets going. Okay, let's practice this. Converting from milliliters to kiloliters. Equivalency equations. Well, I don't have an equation that tells me that exactly how many milliliters is in a kiloliter, but I do have 2 equations. I know that 1,000 milliliters is in 1 liter, and I know that 1,000 liters are in 1 kiloliter. So I have 2 equations. I'm going to expect my new number to be quite a bit smaller, right? Because a milliliter is a tiny measurement compared to a kiloliter. So my new number will be smaller. All right, so let's practice this. We're going to do all the same steps, but we are going to have not 1, but 2 fabulous conversion factors. Okay, first step is always start with my original number. Wrote it too low. Okay, so I have 652 milliliters over 1. Next step, place my units. We want to cancel out of milliliters, so we're going to put milliliters on the bottom. But we don't have one equation from milliliters to kiloliters, so we're going to do this twice. We're going to convert to liters, right, using this equation. And we're going to do it again. We're going to cancel the liters, and we're going to go into kiloliters. Okay, step 3 is we're going to place our numbers. We know that there is 1 liter in 1,000 milliliters, so the 1 has to be on top next to the liter. And we know that 1,000 liters makes up 1 kiloliter. Now we get to do our favoriteest part. And our favoriteest part is canceling the units. Dun, 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 na, 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 na. Milliliters cancels, liters cancels. Then we get to multiply. 652 times 1 again equals, surprise, 652. 1,000 times 1,000 equals 1,000,000. We're going to divide, which is going to move our decimal place 6 places. 1, 2, 3, 4, 5, 6. Or we could do it on the calculator. Okay, 1, 2, 3. Okay, it should be this many kiloliters. Right? Yes, I believe so. Okay, that's my answer if I'm not wrong. If I am, I'm sure I'll hear all about it in class, in Zoom class. Okay, so much fun. Ooh, that's the last one. All right, so now you get to do lots of practice on your homework. And I can help you out in Chemistry Extra Help if you need some help. So, nice job, class. I'll see you later.